Hi guys, it's Professor Grabowitz. Here is another short video, few minutes on the different types of chemical bonds that happen when we talk about chemistry in the body. So in this short video, we are going to talk about the differences between ionic bonds and the differences between covalent bonds. And there's two different types of covalent bonds. There's polar covalent bonds and there's non-polar covalent bonds. So let's begin by talking about ionic bonds. So let's first talk about the interaction of sodium and chlorine in the formation of sodium chloride, which is just actually everyday table salt. Okay. So the sodium ion, the whole goal of this process to begin with is so that the outer valence electron shells are going to be complete. And that outer shell is going to want to follow the octet rule. So it's going to want to have 8 electrons in that outer valence shell. So let's look at sodium first. Sodium has an atomic number of 11. So that means that there's also 11 electrons orbiting in these electron shells. The first shell will have 2, the second shell will have 8, and then that final electron shell will only have 1 sole electron in it. So in order for this to follow that octet rule, sodium will either have to gain 7 electrons, or it will have to give up 1 electron. Okay. So if it gives up 1 electron, which is the most plausible thing that it could do, it's a lot easier to give up 1 electron than to gain 7 electrons. It's going to want to give up this electron, and if it gives up or transfers this electron to another atom, then this electron shell goes away and this outer electron shell will be totally completed. Okay. When we're looking at a chlorine atom, its atomic number is 17, so that means that there's 17 protons in the nucleus and 17 electrons orbiting the electron shells. So that first shell is going to have 2 electrons, the next shell will have 8 electrons, and then that outer valence shell will have a total of 7 electrons floating around. So this makes it an ideal atom to interact with sodium that only has 1 electron in its outer shell, right? So when sodium chloride is formed, this outer electron from sodium will be transferred to the outer electron shell of chlorine. That way, this outer shell of sodium will be completely filled. There's already 8 there to begin with, so it gave up this 1 electron and transferred it over to chlorine. And then that would make this outer electron shell of chlorine totally full. So when sodium gives up that electron, it becomes positively charged, and that's called a cation. And when this chlorine atom accepts that electron from sodium, it becomes negatively charged. And that's also called an anion. So another type of chemical bond that can happen is something called a covalent bond. Atoms that form molecules by sharing electrons are joined by covalent bonds. The shared electrons are going to orbit around each atom for part of the time so that they may be counted in each of the atom's valence shells. Thus, the valence shells of each of the individual atoms will be full because they're sharing electrons amongst themselves. So the two different types of covalent bonds that can happen are nonpolar covalent bonds and polar covalent bonds. Now, when we're talking about the concept of polarity, polarity means that there's going to be an unequal charge distribution between the two molecules. So one molecule might be a little more positive, one might be a little more negative, and those two electrical charges do not attract, so they're going to pull a little bit. Okay? So let's start off by talking about nonpolar covalent bonds. These are going to commonly be found among molecules of the same type. So maybe two carbon molecules are bonded together, or two hydrogen atoms are bonded together. So in the nonpolar covalent bond, the shared electrons are going to spend an equal amount of time revolving between the two atoms. So there isn't any charge difference. Those electrons are going to spend the same amount of time orbiting each of the carbon atoms in that molecule, or each of those hydrogen atoms in that molecule. The nonpolar molecules tend to not mix very well with water, and that term means hydrophobic. So hydro refers to water, phobia or phobic refers to fear. So nonpolar covalently bonded molecules are not going to like to mix with water, like fats. Fats and water do not mix. So the other type of covalent bonds that can form are polar covalent bonds. And just by knowing what the word polar means, there's going to be an unequal sharing of electrons. Okay. Excuse me, I swear whenever I do these videos, I have a cold. So with the polar covalent bonds, there's going to be an unequal sharing of electrons between two atoms. So for example, when we're talking about water, water is made up of H2O, two hydrogen molecules, and one oxygen molecule. So when a hydrogen atom is covalently bonded to an oxygen atom, the shared electrons are going to spend a little less time near the hydrogen atom and more time near the oxygen atom. And this occurs because the oxygen atom has a stronger pull on the electrons. Okay. So just for you to know that if something is polar covalently bonded, there's going to be a pull towards one of the atoms versus the other atom. Okay, so polar covalent bonds they tend to mix. Compounds that have these bonds tend to mix pretty well with water, and they're considered hydrophilic. Hydro refers to water, philic refers to loving. So hydrophilic molecules will like water. So this is really the high-level understanding of chemical bonding that you will need to know for this class. Know the terms hydrophobic, hydrophilic. Understand that covalent bonds, there's electron sharing that happens, and the two types can be either nonpolar covalent or polar covalent. And with polar covalent, there's an unequal sharing of electrons in that outer shell. And with polar covalent, that electron sharing is going to be quite equal. Hope this helps. Hope you have a great day, and I will talk to you soon.